Welcome friends, on the occasion of National Quiz Competition 2020 organized by Raman Science and Technology Foundation, Gujarat, Vigyan Prasar Network, Department of Science and Technology and Aryabhatta Science Club. Today I am going to share my experience and my little knowledge, whatever I know about Dr. Vikram Sarabhai, the founding father of Indian space program, and the journey of ISRO, that is from a small fishing village to moon and beyond. The journey is very exciting, and ISRO has put all its effort to reach from a small church first floor to moon, Mars and beyond. So how did this journey started? So I will talk about 1963, when nobody was so much fascinated about science, at least in India, because we are worried about feeding our fellow countrymen from the agriculture produce even. And we had very shortage of agriculture produce, and we were just trying to cope up with those situations. And that was the time when Dr. Vikram Sarabhai, person who born on 12th of August 1990 in a lavish industrialist family in Ahmedabad, Gujarat, and he had a dream, and he thought that if a country like India has to prosper and develop, then the satellite communication or space technology is the best tool, and it has to be developed in a way so that it can be utilized properly. The benefits should be harnessed in such a manner that a common man of our society be benefited. So in 1963, friends, when he got this proposal and approached the then government that we should do something, we should try to explore outer space. Can you believe that that time whosoever would be in the government would take those things from Sarabhai very seriously? But fortunately, yes, and things started. And in 1963, a small fishing village called Thumba near Trivandrum, which was only meant for fishing. A small handful amount of number of fishermen used to come for fishing. There was no big habitat on that particular small village, and there was a small church on the seashore of that particular village, and fishermen used to come on Sunday to offer their prayer. Now that church then became the laboratory for the space science and technology, for foundation of which were laid by Dr. Sarabhai and team in 1963. And on the first floor, the building of rocket, the experimentation with rocket started, and that was none other than Dr. Vikram Sarabhai. What was his vision? He had a vision, and you just listen carefully to his vision statement. So there are some who questions the relevance of space activities in a developing nation. So we were developing at that time. To us, that means he has in mind there is no ambiguity of purpose. The purpose is very clear in our mind, that how should we, as an India, as a developing nation, should approach outer space. We do not have the fantasy of competing with the economically advanced nation in the exploration of the moon or the planets, or even manned space flight. So he was very clear at that time. He did not have the vision of exploring moon, Mars, or making people land there on the different planets. But what he had in mind, but we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technology to the real problems of a man and society. It was very clear at that time, friends, and he played a key role not only in developing and establishing a great institute like ISRO, but he also had in mind, because he was a very diverse personality, there are very another important institutions founded by Vikram Sarabhai, to name a few: Physical Research Laboratory in Ahmedabad, the Indian Institute of Management in Ahmedabad, Community Science Center at that time in Ahmedabad, Atira. You see his vision that Ahmedabad was considered to be the Manchester of India, and people had lot of problem in doing research for, at least for textile industry. So he established a unit, a research unit called Atira, that is an Ahmedabad Textile Industrial Research Association, right? Then Darpan Academy, he was fond of, not only for he pursued science and technology, but he was keenly interested in dance, drama and the other activities also. He established along with his wife Darpan Academy for performing art in Ahmedabad. Then one of the biggest and the pioneering center of ISRO, Vikram Sarabhai Space Station Center in Thiruvananthapuram, right, and the Space Application Center in Ahmedabad, formed by merging 6 institutions established by Sarabhai in Ahmedabad. They were working in different locations in Ahmedabad, in different buildings, but then he formed a Space Application Center at Jodhpur in Ahmedabad. Then a faster breeder test reactor in Kalpakam, variable energy Collectron project in Calcutta, then ECIL in Hyderabad and UCIL in Bihar. So there are many such institutes which Dr. Sarabhai had played a key role. But he talked about a common man. Now, who was this common man? And today, if we see, we are trying by Chandrayaan 2, we tried to land on moon, right? Again, we did Mangalyaan. So was that the vision of Dr. Sarabhai? But now, if you quite carefully listen to the present chairman, Dr. K. Shivan, he says that Sarabhai's initial vision that space science and technology must be used for benefit of a common man, that became a guiding force for ISRO. And having met all earlier demands, we are on path of planning new seeds, benefits of which will be reaped इन फ्यूचर. अभी जो हम कर रहे हैं उसका फायदा हमें फ्यूचर में मिलने वाला है. तो व्हाट ही सेज फर्दर, दैट व्हाइल continuing with program to benefit a common man, ISRO is looking at exploring space to find solutions for present day and future problems, and that learning from current mission will be again solution for the future problems. So this is what his vision. Now it is contemplating into the real benefit, right? And all this year, ISRO always has in focus that common man only. ISRO was that time in a first phase. Now it has entered into the second phase now, and our main focus is still that common man. But now the problem of that common man has changed, right? And that will change further in future. So problem of future would be a scarcity of water and energy, and our current space exploration could find solutions to them. Then what Sarabhai thought of? He never thought of making any satellite first. He never thought of making any rocket first. He decided that at least if I want to make aware about the technology and take my country further in the road of development using that satellite technology, let me tell and let me get very close to my people to that technology, how to use that technology effectively. And if they are convinced, then there would not be any hindrance in going ahead with those technology. He hired one ATS-6 satellite from NASA, Advanced Technology Satellite from NASA, and it was parked over Indian continent, and the experiment called SITE, Satellite Instructional Television Experiment. Till today it is considered to be one of the largest socio-economical space experiment conducted ever in the history of mankind. Using this satellite, what happened was that in the 6 different states of India, 2400 villages were selected, and agriculture, educational and entertainment programs were being telecasted regularly for 2 hours in a day, 1 hour for this educational and this purpose, agriculture purpose, giving the good information, new technologies, and how with available resources a farmer can can have more produce of agriculture. Then a small for 45 minutes to 1 hour entertainment program. So that was the beginning. And today whatever we talk about DTH, direct to home technology, at that time in 1975, that was the time I am talking, that was the time that using ATS-6 satellite, this biggest experiment was conducted, and he had signed an MOU with NASA's Dr. Payne, right? And this satellite was kept there for 1 year. Then what happened was that ISRO started thinking of making a satellite, right? And the journey started with Aryabhatta, as you all know, in 75. It was a very small satellite. We just wanted to know that in a very hostile space environment, whether the artificial satellite, can we make that satellite? Can the satellite made by us will survive in space environment? That was the initiative. So that was a very beginning time, and it was, we were learning those things. We learned that, we made Aryabhatta and we launched them that satellite using Russian rocket. Then we made Bhaskara, then Bhaskara 2, then came Rohini series. That was the early bird satellite, right? We were learning. And then came in 1980, because these were parked in the lower Earth orbit. And the most interesting orbit in the satellite communication is considered to be the geostationary orbit. And for geostationary orbit, to know that orbit parameter perfectly, what we did is that Vikram Sarabhai had good rapport word over with all spacefaring nation, and ESA at that time had developed one rocket called Ariane. So after some hiccups in the initial flight, they were now ready for the commercial, the test flight of Ariane rocket, and they requested ISRO India that if you are able to make one communication satellite of about 500 to 700 kg, because that was the weight available to be carried on Ariane rocket, then we will launch your satellite for free. So we took up that challenge, and we, in a span of 1.5 years to 2 years, we made the country's first indigenously developed communication satellite having 500 to 600 kg of weight. Only 2 TV transponders used mainly for TV broadcasting, and we used only one frequency and 2 transponder, one main and one redundant. That was the beginning, because we wanted to know whether the satellite which was made by us, will that survive, how we can make it stable in that environment, because Ariane was only to launch that satellite, but we have to keep that satellite stable in that geostationary orbit, and we have to see whether we can uplink it properly, where we can orient the satellite properly, looking exactly pinpointing towards India. And we wanted to conduct the experiment, and we did it very successfully. Then came the second era of making modern satellite. INSAT 2 series, INSAT 1 anyway was design was us, then we fabricated by one American company. Then we started with INSAT 2 series. It was totally designed and developed in India by ISRO, and we had INSAT 2A, B, C, D, like that, all series. And then what happened was that we started building a satellite of 6,000 kilogram class, and we pumped not only single transponder but of the order of more than about around 50 and more transponder in a single satellite. At the time we used only one frequency, that is C band at 4 gigahertz. Now we are using a bouquet of frequency. We are using S band, we are using C band, extended C band, KU band, and some experimental Ka band in a single satellite. So that is the technology we have traversed. So from a small 500 kilogram satellite to 6,000 kilogram class of a satellite, only one frequency, to bouquet of frequency, that is the journey what ISRO has traveled. And then we talk about developing small rockets. So the rockets which we developed was first was a sounding rocket from Thumba, and Thumba was selected because the magnetic equator of Earth passes just over Thumba. That was one of the biggest reason. The advantage of magnetic equator is that the equatorial electrojet passes exactly over Thumba, and that plays a very vital role in the upper atmosphere. So sounding rocket, which were initially launched by ISRO from Thumba, that is called TERS, the main purpose was to have a clear and detailed study of the upper atmosphere, right, up to say 100 kilometer or less than that, or maybe in the later series a little above 100 kilometer. So what we used to do, we used to fire them, and it was all solid propellant, and this rocket would go up. Then on the top there would be a nose cone where our electronic payload or instrument would be there, and when the velocity of sounding rocket becomes 0, right, then it would start descent phase, right, it would start coming down, and with the help of a parachute all the equipment by and ground command will be switched on, and it would start taking measurement while the descending phase of the rocket flight. The payload would come down, and all the instrument, the important parameter like the temperature, wind velocity and humidity, like this important parameter on the vertical profile of the upper atmosphere was being carried out. The biggest reason for this was the balloon cannot go to that height to take your measurements, and satellite cannot come so much low, because then it becomes unstable. You have to keep your satellite to certain altitude in order to make it stable in that particular orbit. So that was the reason, and that was very crucial to understand. So that was the missing part. It was being taken care by our sounding rocket. From there on we started, and then we made SLV. SLV has its own story, friend. Satellite launch vehicle. It was a team building phase for ISRO. ISRO passed through many phases: learning phase, then after conceptualization phase, then learning phase, then operational phase, realization phase, right? And we learned a lot from our failures. SLV3 of the Professor Abdul Kalam was the project director for that mission, and here I want to share a small thing about how the leadership of ISRO has taken this great organization to such a height today. At that time we had Satish Dhawan was the chairman, and the responsibility of developing SLV3 was given to Dr. Abdul Kalam as a third team. There were 3 teams selected, and his team was number 3, so it was named as SLV3. He was given a responsibility. The first flight in 79, everybody was called, so many big shot politicians and everybody was there, and press and media was also there, and they had a flight, and Abdul Kalam was to address the press conference, right, as usual, being a project director, mission director. And what happened? First flight, after the first, it took off from the launch pad, and within few seconds, right, the error built up, and what happened, that the entire rocket went to the Bay of Bengal. That the press was there, and he was, whether it's a success or failure, you have to address the press, you have to tell something. So he was shivering. But then came our Professor Satish Dhawan, the then chairman. He knew the situation, and he told Dr. Abdul Kalam, okay, there is a cafeteria next door, you just go there and have a good cup of coffee, I will face the press conference. And he told press that, friends, we have a failure. You see, the first sentence he uttered was, sir, friends, we have a failure, but now we will understand the failure, and I am assuring you that within 1 year time we'll come back and we'll show you that we are successful, right? And exactly within 1 year, 1980, in the month of July, same chairman, same project director Abdul Kalam, same SLV3 team, they made another rocket. They analyzed so many things, they understood each and everything, whatever failure took place, and then it was, the correction was made, they were implemented, and they undertook the second flight of SLV3, and it was a grand success, and we entered the elite club of spacefaring nations. That was the beginning. But then again, there was a press conference, and Abdul Kalam was there, Satish Dhawan was there, but this time Satish Dhawan told Abdul Kalam that okay, now there is a cafeteria next door, I am going there to have a cup of coffee and now you face the press conference. This is the leadership. When there is a failure, he will come in front and face the situation. When there is a success, he is always push his juniors forward and take the credit. This is the foundation of ISRO and how it has groomed, and we are very lucky as a country that it is still continued and the legacy has heritated, and we are continuing on the footpath of the great leaders of India. So then what we did was that we made SLV, then we made ASLV, right? And augmented satellite launch vehicle, again till ASLV we had used all solid propellant. We did not use any liquid propellant. Then we made PSLV, right? PSLV is considered to be the workhorse and the most reliable rocket in the world today. It has got 50 successful flight. Only 2 initial flights had a little problem, and one in the later stage where the heat shield could not open up to inject the satellite into space. Otherwise 47 and almost more than 40 consecutive successful flight, that has got a record of its own. And friends, you all know there is a record of putting 104 satellite from a single rocket. That again is a record. Placing 104 satellite is not a record for ISRO. For ISRO, because out of 104 satellite, only 3 belong to ISRO and 101 belong to different countries, right? Like USA, Canada, Germany. And because they belong to different countries, they had a different destination to go. So for ISRO, the biggest challenge was to inject and put those satellites into correct orbit which they belong to. Because if you place the satellite correctly into their intended orbit, then the onboard fuel of that satellite is saved, and the total time for which the life of a satellite is designed, they can make use of that. All the experiment can be done, and throughout that mission lifetime the satellite can survive, right? So that was the biggest challenge. And then cryogenic engine development, that was one of the biggest bottleneck for ISRO and India. And what happened was that we were to develop cryogenic technology with the know-how from Russia, but due to US intervention we did not get that technology. I am talking about 91, 92, but ISRO then decided to develop their own rocket technology, and in the year 92, right, 91, 92, we decided that we will go off our own, and from there onwards we took almost 18 years to develop this cryogenic technology. And today we can very proudly say that using CE25, that 25-ton cryogenic engine, now we are self-reliant, and we have developed our GSLV Mark III, right, which has taken our Chandrayaan 2 almost to the moon surface, right? We reached almost there. Only few meters were left. So we showed the world how to reach to South Pole of Moon. So that is again GSLV Mark III. So that also is a story in its own. So we made SLV, ASLV, PSLV, and then GSLV. So, and this story, then we made satellite of remote sensing, right? So we made remote sensing satellite, we made communication satellite, then we had navigation satellite. Everybody knows Kargil war, but at the time of Kargil war, our strategic forces needed GPS services to locate their different troops and know their locations, because you don't know in at that time in those terrain you don't know. So America's GPS satellite service were taken by our Indian forces, and what happened that on the crucial time they stopped these services. We are in great problem, but again it was our own Indian army. We came out with a flying color. It was a greatest landmark victory in the history of India. But that time ISRO and India decided that we cannot depend on any other country for such type of services, especially for our strategic forces. Then we decided we should have our own navigation system. So following that, we made Indian National Regional Satellite System, called IRNSS. We had already put 7 such satellites into space, and very soon we will be using our own satellite system. So we had made that navigation satellite. Then we made scientific satellite. We have our own space observatory into space, multi-wavelength space observatory known as AstroSat. Right? So these are the kind of different class of satellite ISRO has made, different kind of rockets like from SLV to GSLV. So this journey of remote sensing, the first resolution was 1 kilometer. So that is considered to be very, very poor resolution. And nowadays, whatever resolution we are getting from our remote sensing camera is less than 1 meter. And our future technology, very soon it is coming on our remote sensing camera, that if you have your dinner plate in your hand and if you are going on your terrace, our satellite will pinpointedly tell whether you are eating dosa or a puri from your dinner plate. That is the journey of ISRO, and it has taken 50 years, my dear friend, to reach from 1 kilometer to few centimeter in terms of resolution, from only 500 kilogram to reach up to 6,000 kilogram class of satellite, from 2 transponder to 60 transponder. ISRO has taken this 5 decades, and now that is the reason that blood and sweat of Indian scientists has gone into it, and that is why we are considered to be from 1 to 4 in the spacefaring nation today. And lastly, some of our future mission, I would like to talk about some gisat. That if you want to imaging the Earth, we are doing it, still we are doing, world over people are doing, but at lower Earth orbit. So imaging the Earth from a geo orbit, it's a challenge in it itself. So we are targeting that using gisat because it gives you and 24 hours visibility when you are at geostationary orbit. Then we have Aditya L1. We already have one of the lecture in this series on Aditya L1. Why do we want to do Aditya? That is study our study of sun. To study coronal mass injection will be kept at the satellite will be kept at Lagrangian point L1, right? And one more proud moment for India coming very soon is NISAR satellite, NASA ISRO synthetic aperture radar, right? NASA has come to ISRO to collaborate for making one satellite. That is the proudest moment, because ISRO is the only organization who has successfully developed dual band side looking airborne radar, which is very crucial for this mission. And at such a competitive or cheap rate, I would tell you that even the chief of NASA at that time, right, when there was one common meeting, and he asked that time the people who were very deeply involved in that, how is it really developed? The people, our seniors and our people told, yes, it has been developed. Is it really, can it really be chipped, and is it working? And we showed them, yes, it is working and it can really be made in such a cost. Now then they realized that, because when you make that particular radio emitter operate at both band, that is L and S band, that becomes very crucial and very important, that you can use it not only for imaging Earth but for imaging for any other planet. That is why NASA came to us, and we are making it, and very soon we will be launching that NISAR mission. Then we have got Gaganyaan. By 2022 we intend to launch that Gaganyaan. 3 of our Indian astronaut, I would say Gagannaut, not astronaut, because it is Gaganyaan we call them Gagannaut. A selection of 3 Gagannaut has been finalized. Presently they are under training at Russia, and they will be using our own rocket, that is GSLV Mark III, which will be human rated rocket, and in our own space capsule 3 our Gagannaut will be sending them from our own soil, that is from Sriharikota, and they will be there in space for 1 week time. They are not intending any spacewalk, but they will be doing the pre-decided microgravity experiment, that is Gaganyaan. 2 robotic flights, one at the end of this year and one at the end of next year are planned, and then we will have a manned mission. So many experiments before the actual flight are being carried out. Some of them are already successful. So these are some of the future things. Then we also have to make semi-cryogenic engine. We are aiming for Chandrayaan 3 with the help of in collaboration with JAXA. Then we are aiming at Mangalyaan 2 mission. We are also making a mission to Venus, Shukrayaan. Then again one more follow-on Aditya mission at L5, Lagrangian point, another point in space, that is L5. Then we are doing a SpaceX mission. So what is a SpaceX mission? That is basically by 2030 or maybe little later, we intend to have our own mini space station weighing around 15 to 20 tons, and people there can live for about 20 to 25 days roughly. That is the initial plan. So for that, before that, we want to do this SpaceX experiment. 2 small satellites in space. We intend to do a docking of 2 satellites in space. And once that is done successfully, the attitude and the station keeping system of 1 satellite will be combined and will be utilized for carrying out the total combined mission in space. That is one of the future experiment. So with this, there are some proud moment for ISRO. PSLV, the workshop development of our own cryogenic technology in span of 18 years. The GSLV Mark III, Mangalyaan 1, Mangalyaan 2 to be followed, Chandrayaan 1, 2 and Chandrayaan 3 to be followed. 104 satellite in a single rocket, that again is a record in itself. And NASA coming to ISRO to make a satellite in a joint venture program. So there are many more. I can go on and go on, but this is, I just wanted to share few things. And ISRO at a glance, just 5 simple points. We have done more than 100 spacecraft mission. We have done more than 75 successful launch, 10 student satellite, 2 atmospheric re-entry mission successfully, 300 foreign satellite launched from 33 different countries, earning a very handsome amount of foreign revenues, and it is still counting. This is ISRO for you. Thank you, friends. Thank you for believing in ISRO. Thank you.